What is chemical potential in multi-component systems? Imagine a busy kitchen with many ingredients being added or taken away. Each ingredient's movement depends on its own energy level. That energy level is what we call chemical potential. It might sound complicated, but it's really about how much a tiny change in the amount of one ingredient affects the overall energy of the system. In systems with many different substances mixed together, each component has its own chemical potential. Think of it like a tug-of war where each ingredient pulls in a different direction. The chemical potential tells us which way the ingredient wants to go. If the chemical potential of a substance is high in one area and low in another, molecules will move from the high to the low. This movement continues until the chemical potential balances out everywhere. Now, how does this relate to entropy and spontaneity? Well, entropy is about disorder or randomness. When molecules move from high to low chemical potential, the system's entropy tends to increase. This process happens naturally and spontaneously because it increases the overall disorder. When the chemical potentials of all components are equal, the system reaches a state called equilibrium. At this point, no more net movement occurs, and the energy of the system is at its lowest possible level. Irreversibility comes into play when the system changes in a way that can't be undone without adding energy. For example, when a hot object cools down to room temperature, the process is spontaneous and irreversible. The chemical potential difference drives this change. Once equilibrium is reached, the chemical potentials of all components are balanced, and no further spontaneous change takes place. In practical terms, think about dissolving salt in water. Salt molecules move from a region of high chemical potential in the solid form to a lower chemical potential in the water, spreading out evenly. Or consider a chemical reaction reaching equilibrium when the chemical potentials of reactants and products balance out, stopping the reaction from proceeding further. Diffusion, the process where molecules spread out, is also driven by differences in chemical potential rather than just concentration. So, in multi-component systems, chemical potential acts as a kind of energy gauge for each substance. It guides how molecules move, how reactions happen, and how systems settle into stable states. It's a key piece of the puzzle that links energy, entropy, and the natural tendency of systems to reach balance. Understanding this helps us see why certain processes happen spontaneously and how systems evolve toward equilibrium.